Alright, today we're going to do a whole bunch of things. We're going to classify triangles by angles and sides. We're going to apply the angle sum and exterior angle theorems, and then we're going to name and label corresponding parts of congruent triangles. So, we're going to start out by classifying triangles by their angles. If all the angles are acute, that means they're less than 90, then they're called an acute triangle. So here in the picture you can see that all of our angles are less than 90. That's known as acute. An obtuse triangle is when one of the angles is greater than 90 degrees. So here at E, this angle is greater than 90 degrees, so we call that obtuse. The other two angles then are acute. A right triangle is when one of the angles is exactly 90 degrees. And then we talked about the other two. What do they do if they add together? Well, they add to be 90 degrees, and we call that complementary. And our last one, equiangular, that's when all the angles are equal. So all of our angles, I thought I had a picture here, I must not. All of our angles then here will be 60 degrees to be equiangular. Okay, classifying triangles by sides, we have what's known as a scaling triangle. This is when all the sides are different, so all of these have different lengths. An isosceles triangle is when at least two sides are congruent. And some other terminology, if we have an isosceles triangle, you also get congruent angles, and these are what are known as the base angles. And your base angles will be congruent on an isosceles. The H is what's known as a vertex angle. Okay, an equilateral triangle is when all sides are congruent. If all sides are congruent, then we also know that all angles are congruent. And if we have an equilateral triangle, it's also equiangular. We also can call it regular. A regular polygon, by definition, is when all sides are congruent and all angles are congruent. So we talked about a square is also known as a regular polygon. And beyond that, we start saying a regular pentagon, a regular hexagon. And that will describe all the sides are congruent and all the angles are congruent. Okay, so in example 1, we're going to classify the triangle. Here we can see all the sides are the same, so we can say it's equilateral. If all the sides are the same, it's also equiangular. All the angles will be the same. And then we also said you could write regular here instead of both of those. On B, we have two sides that are the same, so it's isosceles. And we can see that all of our angles are less than 90 degrees, so we would call this an acute isosceles. Here we have an angle greater than 90, so we call it obtuse. And two of our angles are the same, so this is known as an obtuse isosceles. That will make your two sides here the same as well. And then our last one, we have an angle that's exactly 90 degrees, so we call it a right triangle. And because those angles are the same, that means the sides are the same, so we get a right isosceles. And this is a special right triangle, which we will talk about in our next unit. On example 2, it says find x and the lengths of the sides of each triangle. So this tells us we have an equilateral triangle. If you want to draw it, you can. RST, this is equilateral, that means all the sides are the same. So if all the sides are the same, we know that the length of RS is equal to ST, which is also equal to TR. So we're going to choose two of them and solve for x. RS here is 2x plus 2. And we're going to set this equal to ST, which is 3x. And then from here to solve for x, we just subtract 2x from both sides. So 2 equals x. Then we have to find the length of RS. To do this, we put the 2 in here. For x, 2 times 2 is 4, plus 2 is 6. For ST, we replace the 2 where the x is. 3 times 2 is 6. And we do the same thing for TR. We replace that x with a 2. 5 times 2 is 10, minus 4 is 6. And all three of those should be the same length because it is equilateral. On example B, I had a typo when you need to put plus 4 here at the end for this to work. It tells us we have an isosceles triangle, and A is the vertex angle, so that means it's up here. So I have ABC. If that's my vertex angle, then AC will be congruent to AB. So I'm going to use that and replace AC with 3y plus 4 and AB with 4y. We solve it by subtracting y, and 4 equals y. I guess it said solve for x. It should say find x or y in our directions. And then we need to find the lengths of all the other sides. So AB, we do this by replacing the 4. 4 times 4 is 16. BC, I'll do it over here. We replace the 4 where the y is. 3 times 4 is 12 plus 2 is 14. And then also on AC we replace that y with 4. 3 times 4 is 12 plus 4 is 16, and we can see that 2 of our side lengths are exactly the same, and we do have an isosceles triangle. In example 3, it wants you to classify this triangle by its sides, and I forgot to write that in the definition, so it's by its sides. First thing you're going to do is graph it. So here's our triangle once it has been graphed, and we're going to find the distance or the length between AB, AC, and BC. Now there are multiple ways to do this. You can either use the distance formula, or I like to use the Pythagorean theorem because it's pretty quick. So the Pythagorean theorem, you just have to create right triangles. It's not very straight. And take a squared plus b squared equals c squared to find the length of here AC. So this is 3, and the other one is 11. So we take 11 squared plus 3 squared, and that will give us c squared. 11 squared is 121, plus 3 squared is 9, so we get 130. So AC is the square root of 130. Let me rewrite that. Okay, for AB, we're going to do the same idea. I'm going to draw this triangle here. Now you could actually use the distance formula, but I think this is pretty fast. So this is 7, and this other one is 4, so we take 7 squared plus 4 squared equals c squared. 7 squared is 49, plus 4 squared is 16, which is 65. So c is the square root of 65, and that will give AB a length of root 65. So we got one more side to look at, and that's BC. Okay, so the base has a length of 4, and this has a 7. We've already used 4 and 7. We know that 4 squared plus 7 squared will give us 65. And then to find the length of C, or here, in this case, BC, we take the square root, so it's the square root of 65. Since 2 of our side lengths are the same, we know that this is isosceles. In class, we talked about how do we verify if this is a right triangle. Even though it doesn't ask us to do that in the problem, we decided we'd go ahead and figure that out. So we talked about identifying the slope from C to B. From C to B, it rises 7 and goes over 4. And then the slope from A to B, it goes down 4 over 7. We talked about how these are opposite reciprocals. Because they're opposite reciprocals, or negative reciprocals, we know that they are two lines that intersect to form a right angle. So then that does tell us it's not only isosceles, but it's a right triangle. When you do your homework, though, it will only ask you to classify it according to its sides. Okay, the triangle sum theorem says that if we add all the angles in a triangle, it equals 180 degrees. So if I knew two of them, say this was 40 and this was 70, then I could find C there by adding those two and subtracting from 180. The exterior angles theorem, we talked about this last week, that this says that the measure of an exterior angle, so outside the triangle, is equal to the sum, meaning we're going to add them to, of the two remote interior angles. So the angles that are not next to 1, we're going to add those, and that should equal 1. We're going to use those ideas on example 4. It says find the measure of the missing angles. So we are missing the measure of angle 1, 2, and 3. When I look at this, I can see a triangle here and an exterior angle with angle 3. And I know that by using the exterior angles that I can add my two interiors, and that will equal 3. So I'm going to find 3 first by adding those two together, and it's 71 degrees. Then if I know 3, I have a linear pair with 2 and 3, or sorry, 1 and 3. So a linear pair just says that there are two angles that add together to equal 180 degrees and they form a line. They're supplementary. So if I take 180 and subtract 71, I get 109, which is the measure of angle 1. Now the last one to find is angle 2. Again, I keep doing that. Again, I have this triangle here and an exterior angle with 1, so I can see that 80 plus 2 will equal 1, which I found to be 109. So then all we have to do is subtract 80 to get 29 degrees. Now there's another route that you could go about finding that. You could say that 3 is a vertical angle with this angle right here, and so that's the exact same as 3, and you could add 3 and 80 and subtract from 180 to get 2. So either way that you go about doing that will be fine. Congruent triangles are triangles that have the same shape and size. That's important. The 3 angles and 3 sides must be congruent to be corresponding, or must be congruent to the corresponding angles and sides of another triangle. So what we did first is we talked about all of the angles that we see that are congruent. So we talked about angle A. This one is congruent to angle R. We can see that by the markings on our picture. Angle B is congruent to angle S, and angle C is congruent to angle T. Our sides that we would show would be AB. Because I started with A on my second triangle, I need to start with R. So AB can be congruent to RS. We have BC. That would be congruent to ST. And then our last side, AC, will be congruent to RT. We talked about how order matters, that angles need to line up. Because we could show all 6 of those pieces, we can say that triangle ABC is congruent to triangle, and because I started with angle A, I have to start with angle R, because those two are corresponding, they line up, they match up. And then I have to move to B, so the angle that matches B is S, and end with T. Example 5 says to identify the congruent triangles. Now, here we can see that we have congruent sides and congruent angles, so we're going to say triangle ABC is congruent to triangle JKL. Make sure that the A lines up with the J, The B lines up with K, and the C lines up with the L. On this other one, I needed to have these on here, and I just didn't. Sorry about that. But these other symbols mean that they're parallel, and from parallel lines cut by a transversal we get angles such as those that are congruent. So we know that those alternate interior angles are congruent. And then I can switch those sides. We can say that this, whoa, no I can't. We have parallel lines like this cut by transversal, so we can say that this one's congruent to that one. So those two are congruent. There is a theorem, and we haven't learned yet, but I'm going to tell you we can use it now, that says that if two angles of one triangle are congruent to two angles of another, which is what we've shown with our angles, then the third angles are congruent. So we do have all three sets of angles are congruent. We have two sets of sides, and the last side that we can show would be congruent would be this side in the middle. And because we've shown all three sides and all three angles are congruent, we can say triangle KJM is congruent. And because I started with K, the angle that's congruent with K would be M. And I went to J, so I've got to go to L next, and then to K. On 6 it says verify that the following transformation preserves congruence, and then name the transformation. So to do this, we're going to find the length of T to S. To do that, you can either use the triangle method using the Pythagorean theorem, or you can use the distance formula. Now the Pythagorean theorem is pretty quick. I can take 1 squared plus 2 squared, which is 5, and then take the square root. So ST is 5. I'm now going to find the length of S prime T prime. And I have this triangle down here. It looks like I've got 2 and 1 again, so this will also be the square root of 5. Okay, my next one that I'll do will be R to S. Now R is the same in both of my figures, so I'm going to do RS first. It's 3 here, 3 here. 3 squared plus 3 squared is 9 plus 9, which is the square root of 18. And then I'm going to look at RS prime. And it also is 3 and 3, so I'll get the square root of 18. Okay, the last length that we want to make sure preserves congruence is from T to R. So that's 2. The bottom one is 5. So RT is 2 squared is 4 plus 5 squared 29 is, 25 plus 4 is 29. And then I'll look from R to T prime. That also is 5 and 2, so we get the square root of 29. And here we've shown that all three sides are congruent, so it does preserve. I'm going to say yes, it preserves the congruence. And the type of transformation it flips over, we call that a reflection. We also talked about the other kinds of transformations. You have a translation, which is a slide, and a rotation, which is a turn, and a dilation, which changes your size. So hopefully that will help you with your 9-5 triangles. Good luck.